Hey everyone, let's solve this equation for x. So you might notice that this equation is in quadratic form because this first term over here, 2 to the 2x, can be rewritten as 2 to the x to the power of 2. And then we can go ahead and rewrite the rest of this as 5 times 2 to the x plus 6 equals 0. So 2 to the x appears here and here. And when it appears here, it's squared. And then when it appears here, it's not squared. It's raised to the power of 1, which is just 2 to the x. So this equation appears to be in quadratic form, which means that we can let a new variable, we're going to let a new variable u equal 2 to the power of x. And what we're going to do is substitute 2 to the x with u. So this just becomes u squared minus 5 times u plus 6 equals 0. And now we just have a quadratic equation that we can easily solve. And this particular one we can solve by factoring. So let's go ahead and factor this. We have our parentheses right here equals 0. We have u and u. And now for this term 6, what two numbers multiply to positive 6 but add to negative 5? Well, that's negative 3 and negative 2, because if you multiply them, they get positive 6. And if you add them, you get negative 5. So u minus 3 and u minus 2. And then solving for u here, u minus 3 equals 0. In other words, u equals 3. And then over here, u equals 2. But remember, we're not done yet because we've solved for u, but we want to solve for x. So remember that u equals 2x. So we're going to substitute that back in. U equals 2 to the power of x. So 2 to the power of x equals 3. And 2 to the power of x equals 2. Now we can solve this one pretty easily. 2 to the power of x equals 2. That must mean that x equals 1, because 2 to the power of 1 is 2. But over here, 2 to the power of x equals 3, we're going to solve that using logarithms. So we can rewrite this as x equals log base 2 of 3. And those are our two solutions for x. Log base 2 of 3 and x equals 1.